So as I'm going to take these derivatives, now what is the derivative of x cubed? We've definitely done that one before. Francisco gave it to me. Keaton maybe did, but I only saw the last motion of his hand. Go ahead, unmute yourself. No, go ahead, unmute yourself. Don't be shy.
3x squared.
There we go. Want to take a wild guess about at least how the derivative of y is going to start? Give you a hint, it's very similar. Keaton's either got an answer or he's doing the disco. It's hard to tell which.
Take the exponent down.
Uh-huh. What do you think we're going to do next? Again, very similar to the last thing we just did. Cormac, go ahead.
3y squared.
Mm-hmm. And Emily, you got it too? Y squared, and the only difference is then we tack on another term. And that term is, we explain that we're going to take the derivative of that y variable with respect to x. And so when I say that we're complicating things ever so slightly today, that's how we're complicating things. The worst thing about this lesson is going to be the algebra. The calculus is going to be fine. And even then on the algebra, it's like 2 problems that I've prepared that we're going to be looking at. There will be a little bit more. Alright, so a couple more examples. And I bet you can help me with these super fast, learning that trick, or having learned that trick. Alright, I want you to try both of these problems using this trick. It's only when you're taking derivative of y, you're going to have to throw in this dy dx term. Keep in mind, on that second problem, they are being multiplied together. Multiplication does indicate a product rule still. So give those a try. I'll give you a head start. Actually, what we'll do is I'll let you guys annotate on the screen. I'm not going to give the answer. Go ahead. When I tell you I'm ready for it, then I'll have some people annotate on the screen. On your mark, get set, go. Bless you. Alright, now. Whoever speaks up with their voice first, I'll let them make the decision. Should we go with volunteers, or should I volunteer you?
Volunteers.
Alright, Andrew. Andrew said volunteer, so that's what we're going to do. If I don't hear anybody volunteer, though, in about 10 seconds, then I will volunteer you. Alright, so I'm looking for 2 people to do these problems. First come, first serve. Who wants to do them?
I can do one.
Alright, Andrew's got
I
one.
can also do one.
Cormac's got the other. On your mark, get set, go. Whoever draws on that problem first gets that problem. I'm liking the annotate feature. I'm going to try to use that one more in your class. I just started using it a little more in physics. And then all of them said, oh, but the handwriting's so sloppy. And I go, I see your handwriting on a regular basis. It's always sloppy. Using the mouse doesn't make it that much worse. Right, looking good, looking good. Alright, so for the first problem, the derivative of the x part is exactly what we've been doing this whole time. Derivative of x squared is 2x. And the derivative of the y part, you treat it just like you would the x. You take 4 times 3, to subtract 1 from the power, and then you put this dx dy term afterwards that's being multiplied by. On the second one, we do need to use the product rule. So we are going to do a first d second plus second d first. First d second plus second d first. And I will just say, but again, remember, the thing I love best is you were brave, you went for it. Aurora, I just saw your comment. Is that just for today? Or just where the mouse is? Yeah, that makes sense. Alright, so on this part, it's when you take the derivative of the y part that you'll put that extra term in. So, your pieces, as I line them up, it's just going to change here. And then the derivative of the x with respect to x is 1. So just this term is going to be over here, and then the y does go on top. Which, this is so new to you, there's no reason why that should make sense yet. But that's something that we'll get to mostly through today's lesson, a little bit through next time's lesson. But lovely, lovely, lovely. If you have these answers, give yourself a pat on the back. There we go. Good job, Mia. Alright, so let's bump it up slightly, but only slightly. Oh, I surprised myself because I forgot I just turned on the annotate myself, and I was expecting one from Paint.
Is that a -4 or a negative y?
-4. Very good question. Am I looking for the whole? Yes, I'm looking for the whole equation. Cormac, I do think you are correct as well. Although, I helped set up that computer lab, and I know for a fact that when I set that up, I put all of the mice on the right side. So apologies, Aurora, partially my fault. They decided to put new carpet into the computer lab just a couple weeks before school started, and or also ordered new desks and tables. And so, like, a week before school was starting, we went back for faculty meetings, and, like, there were no computers set up. And Lori and I are like, ah! Because my husband does IT, and I know how long it takes to set up a computer lab. So while she was trying to fight all the fires all the faculty had, I was trying to help her with those computers. Alright, so, first of all, let's graph this. If you don't have it copied down, don't worry, I'll be back. If I go back to my graph, and graph that equation, once you put Q or Y's and stuff, like, it just gets more fun. So I do recommend that you do spend time graphing the functions that you're being asked to solve for. Because they're going to give you all these shapes that we just never have a chance to play with. So here we have our shape. The point that I am opting for was that point -3, -1, which I had found was definitely on the graph before I did the problem. And we're going to want to find the tangent line. So I know just from what a tangent line looks like, I'm expecting to see something that goes like that, right? Let's use the calculus to find exactly what that equation is and go through that process.
I have a question.
Uh-huh.
Like, like the TI-84s, how would I put in the Y? Like,
Honestly, that's the issue with an 84. Is when I've taught calculus before, and I did have primarily 84s, when we did implicit differentiation, it was that moment where I would have to say, in this moment, sorry, there's not really anything we can do with your calculator, because TIs are designed for when you do your function button. It wants a function, and by definition, remember, functions are, you only have x's in the equation. Functions and equations, while they're related, they're not the same thing. So this is an equation because it's got an equal sign, but a function must pass the vertical line test, and that means if you draw a vertical line anywhere, it's only allowed to pass through one point, and if it does more than one, it's not a function. And so because it's set up for functions with the way it does its equations, it cannot handle function or equations like this. So for this lesson, and this lesson really only, I do recommend using Desmos. Your calculators, your TIs are fantastic, but unfortunately in this case they won't work. If you have an Inspire, I think it will work, although I'm still learning Inspires myself. And I don't remember all the tricks to them, but I believe that they will work there. But on the 84s, 83s, 86s, 89s, 89s maybe they'll work. But anything below an 89 definitely won't.
would questions like this on the AP test, get like the Y's and stuff?
Yes, but they wouldn't ask you to graph it.
Oh, okay.
Yeah, and so I want you to graph it for today to get used to the shapes, because, again, they're fun. But on the AP test, and you'll see in your homework, too, there will be some where they'll say to graph it, but there'll be plenty where they just say, just take the derivative, find the tangent line. And that you can always do without the calculator. So, yeah, it's mostly my personal preference. I was having you graph some of these, and even then, I'm not going to have you graph all of them. But just to get used to and appreciate how different these can be. Okay, so if I want to find the tangent line by definition means I gotta do what to my equation? I think JC maybe said it. Cormac said it. There we go. Derivative. And why do we need to take the derivative?
So you can plug in the point where the line would be at.
So we can plug in the point. When we plug, we'll do an arrow there. Plug in point to get specifically the slope of the tangent line. And I know I'm just going to keep saying this because it's easy to forget when we spend so much time taking derivatives why we're doing it. So, would you take the derivative for me of this equation? I'm going to give you almost a minute's head start, and then I'll do it too, and we'll compare answers. And then I'm going to show you how we would use this to find the slope, because there is a small bit of algebra involved after we do the calculus. While you're doing that, I'm going to go ahead and mark all of you that came in present, because I still got you marked absent. Let's see, one thing I don't think I did before is it is a legal move, and in fact it's needed, that if you're taking the derivative of one side in this sort of situation, that you do take the derivative of the other. And it is okay to write it like this. And Claire, yours is almost exactly correct. It's upside down and there's one other tiny little thing that is different, but you've got it for the most part, so good job. And what I'm really excited about is you actually did the algebra too, not just the calculus. Which I haven't even shown you how to do that, so good job. All right. All right, compare your work to mine. As we take the derivative, we get this new equation. The problem with this is our derivatives, the thing, the dy dx, the f prime, the y prime, whatever you want to call it, it's inside the equation. Where the derivative, this slope of the tangent line, is the derivative. So we've got to do some algebra to pull it out. We want to see dy dx equals blah, 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 blah. Okay? And so this is where the algebra comes into play. Does anybody have any ideas about how we could reorganize our equation to get that dy dx out on its own?
You could factor it out.
We could factor. Perfect. Let's factor out of everything we possibly can factor. But then again, not anything more than that. All right. Now, we want to get dy dx by itself. Have I told you before, equations are like ogres? Some yeses, some nos. Definitely yeses from the people who had me before. They have layers, and you gotta peel back the layers one at a time. So, on this equation, if this is what I want to solve for, and it's attached to something, and then that is associated with something else, what is the outside layer we gotta peel back? What do I move first? Keaton, just say it.
2x.
What? Say it, Francisco.
The 2x.
The 2x. I gotta move that 2x first. So, how do I move the 2x?
Plus 2x on both sides.
Okay. If I do it on one side, gotta do it to the other. And it might seem trivial, but people make mistakes on this sort of thing all the time. All right. What do I do next to get dy dx by itself? Keenan's leading the orchestra. What do I do next?
Divide.
There we go. Francisco's got all the answers today. Actually, no, plenty of you have had the answers. He's got the answers on this part, though. Alright, we're going to divide by the stuff that is not dy dx. And if I do it on one side, I do it on the other. And I see some things cancel. And I now am left with an equation that gives me my slope. Something that I can plug the numbers into, and bam, there I go. And so at this point, let's go ahead and plug in the numbers. At -3, -1, this is going to be equal to, put in the -3, put in your -1s. Go ahead and simplify, and tell me what you get. Maybe, Keaton. Maybe. Mostly because I only caught part of what you were waving. Yes. Cormac gave it to me on the screen, even better. Which is great, because Cormac, you've been frozen for a while on my end. Your face is just kind of... There you are.
Wait. Oh.
But you heard me, you wrote it on the screen. Alright, and I don't believe any answer till I hear it at least 3 times. Now I've heard it twice, or just heard/seen, because Keaton did mime that to me. But I don't believe it till I've gotten at least one more confirmation. Oh wait, Francisco, JC, I see in the chat you gave it to me. Alright, perfect. So, if I want now... Oops. Wonder if I can move your drawing. I've not tried this yet. Oh, no. Move. Yay! Oh, I learned something new today.
That's a rather large 3 halves.
What do you mean? Oh, I stretched it?
When you stretched out it.
Yeah, that was. It was very, very tall. You never knew 3 halves was so big. Alright, so my equation... Now remember, I'm looking for an equation of a straight line. I could do y equals mx plus b, which is the one you're most familiar with. I could do standard form, which I will tell you, you need to know how to convert back and forth between standard form and other forms. But in my opinion, standard form is the useless one. It doesn't tell you anything on the graph, so I'm never a fan of it. I don't know why that just left that behind. But the one I think is the best option right now is actually our point slope form, which is probably everybody's least favorite. But here's why I like it. It's the easiest to use right now because I have a point, I have a slope, there's no work to be done, all I have to do is plug it in. And so remember, it's where the y1 and the x1 go. And also remember, this is just a rearranged what am I calling it? A slope equation. All I need to do is plug in my numbers in the right places and maybe simplify. In this case, I will want to simplify because I've got minus negatives. But that's it. I'm done. If I try to use one of the other forms of the linear equation, it's going to take more work. So I've said before, anytime I can introduce you to this point slope form, I'm going to introduce you to it because it actually will be easier and faster for you as you get used to it. And I'm going to wait till you've got that, and then we're going to go back to the graph and see if we got the answer right. Because the best way to check it is to see if we got that line we predicted originally. So when you finish copying stuff down, just have a staring contest with somebody on the screen.
Is there a way I can stop annotating? Because whenever I go to adjust the zoom screen,
It annotates? Yes. So do you see where you have like the option to pick your colors, eraser, blah, blah, blah? Make sure you're on mouse. If you're on mouse, it'll stop annotating. I've had that issue a couple times. In fact, even just today, I've already had that issue once or twice. All right. It looks like I've got most people looking at the screen. Although Brooklyn, I only see her ceiling. There we go. All right. That's how we're texturing our ceilings here, too. Not obviously in this room yet, because there is no ceiling, but eventually. Okay, so if I type in that equation, y plus 1 equals 3/2 parentheses x plus 3. Oh, that's why. It's in the wrong place. Voila! How'd we do? Got a thumbs up from Keaton? And from Annie, and from Mia, and from Gabe. It's right where we expect it. Alright, so how do you feel so far? Am I hurting your brains as much as last week? Okay, good. Am I hurting your brains at all? Is this too boring? Should we bump it up a notch? Mia's like, no, we're good. All right, so let's talk over some problems for a second. More than I'm gonna do these problems, because these are problems that even for me, I had a moment of, hold on, what's wrong with this problem? And I'm actually going to write this in first instead of typing it in. So be aware. There is a problem you might not expect. In some of these, and I'm going to be specific to say tangent line problem and not just derivative. So, for example, this and this cannot be solved, even though they probably feel like they should be. So go ahead and copy this down. These are the sort of problems we're not necessarily going to focus on. You're not necessarily even going to see in your homework. And honestly, I don't know that I've ever seen anything like it on the AP test. But it could pop up. I could easily see it pop up as a multiple choice question to really test your knowledge. And so I want to make a note of this just to remind us that we always need to keep our eye on the prize. We always need to be thinking about what is the purpose of what I'm doing right now. And again, I did not graph these yet on purpose. What do you think the problem is with each of these? And maybe we have to go back. Notice
Is it a circle?
It's a circle. And what is the equation of a circle? I'll give you a hint. The first part looks just like what I do have on both of these problems. In other words, right there. So go ahead. What's the first part of the equation of a circle?
X squared plus y squared.
Uh-huh. By definition, in a circle is x squared plus y squared equals r squared, where r is the radius of the circle. Have you spent time with that equation? Seeing some head nods, some here and there. And again, I know like the math situation you guys have had, especially for the last year, is its own unique situation. And
Was it specifically -4 or is it all negatives?
just that -4 is the only part that's negative. Good question. What's the problem though with having a -4 in that location?
Has a negative
You
radius?
can't find the square root of those.
We have an issue with the square root. It's not that we can't find it. It's well actually it is kind of like I can't find it. So, if I know that my radius squared is my -4, by definition, here's what I do to solve for the radius. And what's the issue with that?
You have to have an imaginary number.
We get out an imaginary number. And what's the difference between an imaginary number and a real number? How many of you have ever had an imaginary friend? Me too. Mine was Twixtifawabbin. He lived in the hallway of our apartment complex. He was... I don't remember him well. But I've been told that I would go into the hallway and visit Twixtifawabbin. My little sister, she would come home every day talking about her best friend in preschool, a girl named Jewelry. And my dad is a preschool teacher, and he went to the classroom next to his, because that was my sister's classroom, and he asked the teacher, and he said, "So you've got a student in your class named Jewelry? That's a really interesting name." And the teacher said, "I don't have a student in my class named Jewelry." Now, I'm not going to get into my big lecture on imaginary numbers right now, but number one, do imaginary friends serve a purpose? It's a way for you to act out behaviors that mimic what you see in life to help you get a better understanding of just what the human experience is about. They absolutely serve a purpose. Saying that though, can I go up to your imaginary friends? Because almost every one of you put your hand up. Can I go up to your imaginary friend and go, boop, on the forehead? Cormac thinks I can, but I think I'd have some difficulty with that.
My imaginary friend's just built different.
Okay. I don't know if I could find him, though. Or her. Or it. So, the whole idea with imaginary is 100% they serve a purpose. In fact, we would not have electronics without imaginary numbers, which is something I'm not going to get into right now. At least not the electronics as sophisticated as we are used to them in present day. But they do not exist on the graph. Sorry, it won't let me write anymore. On the graph. There's my H and the P. Okay. Alright, so if I try to graph this function... I know, I'm not going to finish yet, though. If I try to graph this function, I will see nothing out of it. Y squared, looks like I'm going the other order, doesn't matter, plus x squared equals a -4. Nothing shows up. If I got rid of the negative, 100%, there's a circle. But with the negative, nothing shows up. It's imaginary, can't touch it, still has a purpose, but can't do anything with it. Now, what's the issue here? Oh, hold on. Let me go back to draw. I'll really change the color so you can really see it. What's the issue here?
It's a 0.
Which means your radius is what?
Nothing.
Nothing. So my radius here, which if I were to put that into my graph, notice you actually do have something show up here. You do have a point, but, oh, hold on. Let's see, how am I going to do this? First of all, I need to go back to draw. Second of all, I'm running out of room, so I'm going to draw up here. So apologies that mine is, it looks like your notes sometimes, kind of all over the screen. All right, so you cannot find the tangent line of a single point. It needs to be a collection of points that are creating some sort of line for a tangent line to be able to exist. So I saw these in the textbook. This was actually a statement in your textbook, a small paragraph in the middle of the chapter, or of the section, that normally it's the sort of thing I just skip over. But as I was looking at this one, I was like, I 100% could see the AP test trying to trick you with a question like this. Where it's something that you go, take the derivative. Okay, I'm going to take the derivative. But then if you think about what it really means, then you come to the conclusion it can't actually work. And I could see this potentially being on the non-calculator section, so it's not necessarily something you could check with the calculator. Most everything they put on the calculator section is things that have crazy decimal answers. It's not just graph it and look at it. They're not going to make it quite that easy for you. So I wanted to bring that up. If you forget it between now and the AP test, I would too. We got some time between here and there. But at least I wanted to bring it up and talk briefly about it. Okay. Let's have you do a couple problems. Well, here's the thing. On a scale of 1 to 5, 1 low, 5 high, show me with your fingers how you feel about implicit differentiation so far. Okay, doing pretty good. I am going to go ahead and I'm going to give you 2 problems to do, and then I'm going to do one for you. And then I'm going to teach you a concept that we did skip over when we were doing word problems as well, but it's a super fast, and believe me when I say super easy concept, there's a reason I pushed it off. Okay, I want you to find for me, yeah, I'm going to plug in numbers. Okay. Find the slope of this equation at this point, and another one that's very much like it. And I'm going to give you several minutes to work on this one. This will take a little bit of time to put together. The first one is one you can solve. It's only when you have that -4 that we have the issue. Because it's +4, we're at a good place. Sorry, I didn't see that. I got distracted the way a lot of you guys get distracted. Did any of you ever go to Beehive Academy? Mia did? I just had a friend message me and said he was just offered a job there and he wanted to see if it was a good school. And I told him, go for it. But what was your experience?
It was a pretty good school. I liked it.
Okay, I was going to say, if you tell me it's horrible, I'll tell him, I just asked my student. She said run away.
They have a pretty good robotics team too, so.
Yeah, that is one of the main things I knew about them. They offered me a job years ago, and I turned them down. But it was just because it was almost a perfect fit. But they were just that far away from what I was really looking for. They used to have an FRC team, but now they have FTC, I know. Their FRC team, I believe, they disbanded a few years ago to Cormac. But hopefully they come back to FRC. Alright, be quick, Keaton. I'm responding to people in the chat, by the way. And again, we're not looking for the equation, we're just finding the slope. Although, because I gave you points, if you use the point slope form of the equation, it would go pretty fast. But all I'm looking for here is the slope. Yeah, Cormac, honestly, they probably disbanded their FRC team around the time that you would have joined robotics, just based on your age. Because it's been a few years. At least 2, I would say, probably 3. But I don't think they hosted it this year because of everything pandemic. But they usually do throw the STEM fair. That I don't know if Waterford ever went to it. Did you participate in that, Mia?
Yeah, I did crystals and stuff. It was pretty cool.
Yeah, it's one of the best STEM related events in Utah, hands down. And Beehive is the one that puts that on. I know our robotics team goes not every year, but most years to participate in it. And yeah, I think they do a better job than anybody else out there. Except for, the U does good summer camps. And, which reminds me, I need to send you information about Engineering Day and Science Day. I don't remember if they're doing Science Day this year. But it's one of the few times I give extra credit, so I better hurry up and do that. Because I think that's coming up this weekend. Alright. Hunter, would you pick a number for me between 1 and 10? And Brooklyn, yes.
9.
Alright. 1, 2, 3, 4, 5, 6, 7, 8, 9. Mia, would you answer your favorite problem on the screen?
The first one, for slope, I got √2 over -2.
Oh, I'm looking at it. I'm trying to figure out what I've done differently. And I'm seeing that I made a mistake on mine. So Brooklyn, I was wrong. But your negative, I do think should cancel is the only thing I'm seeing. What did you get for your derivative? Just to check my work against yours.
2x plus 8y times dy over dx equals 0.
Okay, so on that, we are going to rearrange it to solve for dy. And this is where it does look like we have the same thing. So I'm going to subtract 2x, 8y dy dx equals negative 2x. Divide by 8y, divide by 8y. And we get negative, I'm going to go ahead and simplify, so x over 4y. And then we plug in our number, change my color for that, and we're going to have square root of 2 over negative 1 over the square root of 2. Brooklyn, I'm about to take back what I just said and say I was right the first time. Alright, and I've got a fraction divided by a fraction, which means you got to think about my little sister. Flip her upside down. Oh, and I forgot the negative that was up here. And I end up with negative square root of 2 times negative square root of 2. Or in other words, negative square root of 2 squared. What happens to the negative? Wait, now I'm throwing myself off again. Am I? I think so.
I think you forgot the 4.
There we go. I did forget the 4. Let's leave the 4 attached to this. There we go. Thank you. In that moment. Oh, and Annie's got that too. Alright, so anyway, what is the negative square root of 2 times the negative square root of 2? Well, that's a final answer, Annie. I mean, like, what's just the top? Melina.
What was on the 4 at the beginning of the equation?
Right here, I get it because my derivative is even on top and on bottom. So I'm dividing both the top and the bottom by 2, just to simplify. If you don't simplify, it won't change your answer. It's just a good practice.
I mean, the equation is x squared plus 4y squared equals 4.
Right. Here, let's go back. Let's solve this one from the beginning. Oh, that was too big. Way too big. Okay, so if I'm going to take the derivative of my function, and I like to just tack it all into the same parentheses, I get 2x plus 8y equals 0. Oh, and then times dy dx, because those two do not agree. And then I want to solve for dy dx, so I do some algebra. I treat it like it's any variable. And I get dy dx is equal to this negative 2x divided by 8y. And if you got something different, then let's analyze and figure out where it's different. I mean, you notice, even me, I've got it worked out in front of me, but I did not put all of the steps in mine, which is where I always go wrong, because then I have to go back and remember what I did, where it's easier if the paper does the work for me. I should have written all my steps down. So, I am choosing, then, to simplify, because these are both even. It won't affect your answer if you don't, but it's just good practice. And that's where that 4 comes from. And once I have it, then I know that the slope is going to be that same equation, but with the numbers plugged in. Which, I've got a couple ways I could handle this. let's solve it ever so slightly differently than I did just now. Let's multiply this by the reciprocal on both sides. And I want to multiply the top fraction with the top fraction and the bottom fraction with the bottom fraction. So what happens right here?
It becomes a 2.
Becomes a 2. The square root of 2 times square root of 2 is 2. And we're going to keep the negative. What happens right here?
It cancels.
We're going to get some cancellation. The negative again is going to stay behind. So we end up with negative 4. And what does that simplify to?
2 over 4.
1/2.
Which simplifies down to 1/2. So Brooklyn, we were right. Because I skipped steps, I doubted myself. I thought I made a mistake. All right. Let's see if the next one, it takes as long, if I redo it. Hopefully not. Mia, will you pick a number between 1 and 10?
3.
1, 2, 3. Gabe, you got this one. What did you get as your answer for the second problem? For its slope.
I wasn't able to do the second one. I just got finished with the first one.
Okay. Let's take a volunteer, and if not, then we'll do it together. Anybody get the answer for this one? I saw enough heads looking up, I figured that you guys were done. When I first called on you. This one does take a little more work, so let me go ahead and do that with you. Let's do, okay. Let's take the derivative together of our situation. We're going to have a chain rule and a product rule involved here. And it will be a little bit messier, but I promise it won't be too awful. So, our chain rule says the coefficient gets left alone. And then I bring down the power, leave the inside alone, subtract 1 from the power. And then I multiply that by the derivative of the inside. If you didn't get it, write it down. If you did get it, just check your work. On the other side, the coefficient just gets left out in front. And then we're going to use a product rule. So first, d second, plus second, d first. If you feel more comfortable with this, you actually could go ahead and plug in your numbers now. I know the students that I've had in the past, usually when you get rid of the letters and put in the numbers, it just makes a little bit more sense. So if you choose, it is okay to go ahead and plug in what we have here. Just because I do think, and I can see in your faces, you're starting to get a little tired. Actually, today you guys started out a little more tired, but even compared to that, you're getting a little more tired. This is still a legal move. To do that. And then just to handle this as you would. Now you've got to be super careful with PEMDAS here. So parentheses, exponents, all of that. Because there's a lot going on here still. But if you're careful about PEMDAS, that's going to be okay. So this 3, I'm going to leave it on the outside for now. I'm going to focus on inside of parentheses. 6 plus 2 dy dx. And remember, if it's attached to dy dx, you can't just add it to the 6. They're not like terms. This one, don't have a whole lot I can do to it yet. And just take it one step at a time. Let the paper do the work for you. I am going to go ahead and multiply that 3 by the 2. And then this becomes 10 in here. This is still unlike terms, so you still can't put them together. Here, let's go ahead and distribute the 100. Alright, so this becomes 60. And then let's take the 60. I am going to kind of skip a step there and distribute. Let's see. And get it down to something that's a lot more manageable. And again, just be super, super careful. And pick your sides. Let's see, I'm going to go ahead and put my dy dx's on the right. And my straight up numbers on the left. Put your hand on your head when you're finished copying that down. Or solving the problem on your own. And keep your hand there till I say that we got it. In Brooklyn, you got to give me like a thumbs up or something. There we go. So Brooklyn, are you still having the issues with your connection being lost frequently?
No, it's been better now. Sometimes I turn it off when it starts to lag, but
okay. Yeah, keep your camera on as much as possible then. Yeah. I've been kind of lax with you because I'd rather you stay in class than disappear.
Yeah.
All right. Waiting for Hunter, Andrea, Jared, Nelina, and Josie. And granted, half of that is because I can't see your faces anyway. Jared, you've got a puppy. That's a cute looking dog. All right, Nelina and Josie and Claire, maybe I missed you. Are you guys finished? Okay. Okay. All right. last thing I'm going to do today, but I do want to let you know there are a couple things that I'm not getting to, or that I'm skipping over because of the expressions on your faces. I'm going to get you a break. I'm going to put them in a video. You're going to want to watch that, okay? I'll do a video for you this afternoon. This is going to be a really nice place to leave the day, though. Higher order derivatives. This is something that I skipped over from section 2.3. So when we learned the product rule and the quotient rule, the book snuck it in there. Super easy topic. So we are going to have, what we've been doing so far is all first derivative stuff. And you see notations like this. Right? And again, I warned you, we're going to use all of the different notations. What this next bit is about is you can have second order derivatives, third order, fourth order, or really any order. And when I talk about the notation, it doesn't get much more complicated than what I've already learned. Once you get to fourth, we stop doing the tick marks and we put our item into parentheses. I'll tell you though, realistically, you're never really going to go past a third derivative. So while we'll teach you how to take it and what it looks like, we're really not going to use this. And actually, also, I don't need parentheses on this one. This one is just going to be a 4 and a 4. Or any nth, where n can be whatever number you need it to be. And all it means when you have a higher order derivative is you take the derivative of the derivative. And you keep doing it as many times as it tells you to. So if you have a third order derivative, you're going to take the derivative of the derivative and then take it again. So it's not going to be anything too awful bad. I thought I had more room than that. Wave at me if you've got all that on the screen. Or at least most of it. Alright. Got about a third of you didn't wave at me. Granted, three of you didn't wave at me, but you're not writing either, so. And Josie looks like she's contemplating deep thoughts. By the way, this whole business here that I just wrote down, this is on page 125 of your textbook. You can copy it from there as well. I am going to go ahead and skip over here though. So, let's say that we have an equation. Y equals x to the third plus 4x squared minus 9x plus 10. Could you find for me the derivative of this equation? Compare your answer to mine once you've got it. And could you keep taking the derivative again and again until all your terms disappear? Now, not every function would they disappear on, but on polynomials, eventually they always will. Go ahead and take the derivative of the derivative and keep going until you get 0. On your mark, get set, go. Gabe's got his puppy too. Gabe's puppy and Jared's puppy could become friends. You never know. You're right next to each other on my screen. Got a couple people not working.
Is there ever a reason to go beyond, like, the third derivative?
Practically, I have never encountered it. In fact, honestly, usually we end it at the second derivative. But that's not to say there isn't some place where I'm not aware of it. I just can tell you from my experience, which includes more math than most of you will take in your life, I've never encountered it. But potentially, if you go to like some really high order multi-dimensional stuff, maybe. I'm not positive that it would it be accounted for in multi-dimensional, but that's just the place where it makes the most sense to me right now. In electronics, in just motion, I honestly, I can't even remember using a third derivative on those. I think I usually ended after a second derivative. Mathematically, though, we want to teach you just kind of mathematically what's possible. Again, we teach you imaginary numbers. The only time any of you will actually use an imaginary number is if you're studying electronics engineering. Electrical engineering. Not the hard and fast rule, but almost. Alright. And Hunter, I just saw your message. Are you still there? Okay. Compare your answers to mine. And I am going to point out, like I said, I still have some problems that I had prepared for you, which I knew I was really pushing it to stuff a lot into this lesson, that you are going to want for your homework. I am not going to put them off until Thursday, because we're doing related rates on Thursday, and at least for some of them, you need to have this before then. Okay? I promise I'm not going to make a super long video, though, but here is what we have not covered so far. I have not shown you, let's say, I'm going to show you why the derivative of your inverse sine is equal to something that looks like this. It uses implicit differentiation. It's going to be it's not a huge mind-blowing problem, but it's one you're probably going to want to see. I have not shown you, say, the derivative or a second derivative of an equation. So while I just taught you higher order derivatives, I've not actually used them in implicit differentiation. I should say in an implicit. Again, not terribly difficult, just going to require some substitution. Both of these problems require some substitution that might not be evident to you. So I want to make sure I do an example problem for you. And then the last thing is towards the end of your homework. Not the last two problems, but like the 3 or 4 problems before it. You're going to be asked to find normal lines and if equations are orthogonal. How many of you have had or are currently in physics? Okay, I know a bunch of you because I've had a bunch of you. In physics, what does the word normal mean? Or where do you see the word normal? Do you see it while you're doing momentum? Do you see it while you're doing motion? Do you see it while you're doing forces? Do you see it while you're doing electricity? We're already 2 minutes over class, and I'm not letting you go until you answer my question. Where do you see the word normal in physics? Emily gave it to me. The normal force. In physics, you see the normal force, which, if you haven't had physics, I do apologize. It's one of the most brilliant subjects out there. But the whole idea of a normal force is it's your support force. That is, gravity's pulling you down, normal force is pushing you up. Now, I don't think even Hendrick's class has gotten to this one yet, but if you took physics last year, with either of us, you've seen here, if you have a box on a ramp, your normal force is actually going this way. So just a refresher for those of you that have had physics. The word normal means perpendicular. It's perpendicular, a normal force is perpendicular to the surface that you're sitting on, which is why it's at an angle. Normal lines are perpendicular to tangent lines. And remember, if two lines are perpendicular, then their slopes are what are called opposite reciprocals. So the slope of the first line will equal the opposite reciprocal of the second line. Opposite meaning the sign goes from positive to negative or negative to positive. Reciprocal means you flip it upside down. And while we're on the subject, orthogonal also means perpendicular. The further you go in math and physics, the more you're getting away from the words perpendicular, and the more you're going to see the word